Welcome. Thank you for the wonderful introduction. My name is Asim Hussain. You can find me on Twitter as Jawache, not Jawashe, Jawache. And I blog about Angular and JavaScript and various other things on my website, codecraft.tv. And I'm what's called a cloud developer advocate at Microsoft. So we're a fairly new team inside Microsoft. We've only been around for about a year. That's our mascot, Bit. So we are the open source developer advocates. So my specialty is JavaScript. We've got people inside the team that specialize in all different types of technologies. If you go to the link at the bottom there, you can find all of us. There's about 60 of us right now. I'm also, anybody here know Udemy? Anybody here my student on Udemy? Yes, a couple hands up, fantastic. So yes, I'm also an instructor on Udemy, and recently they added in automatic subtitling for my text, and they correctly replaced my name with awesome. So hopefully this talk will be very awesome. But really, over the past, say definitely the year or so, things have changed for me. So perhaps, this is my friend's slide. So perhaps this is a way to describe kind of what's happened to me over the last year. I started web development, and I've gotten very much into machine learning. I used to be into machine learning a long time ago. I used to be a Python developer back in the day. So what me and Eleanor, is her slide, what me and Eleanor did in London earlier on this year, we're both very interested in machine learning. We're both very interested in JavaScript. We knew there were some very interesting things happening inside this space, so we started a meetup group in London called AI-JavaScript, which has actually been growing very, very fast. We're really happy and proud of it. And if you've got any good questions later on, I have stickers, AI-JavaScript stickers, if anybody wants any of them, in exchange for a good question. So one of the things that happened when we created this meetup in London is a lot of people then send us demos for interesting, cool, AI-powered JavaScript projects. And we thought, well, what we really want to do is create a website where we can just put all of these demos so we can show people what interesting stuff's happening inside this space. And that's exactly what we did. We launched it, I can't remember now, a few months ago. It's called AI-JavaScript Rocks, AI-JS Rocks. And if you go to the link there, what you'll find is that a whole bunch of AI-powered JavaScript demos. Each demo will have at least a link so you can play around with it in the browser and get inspired by what's possible. But then also it should have at least a link to the source code so you can read and understand how they built it. And hopefully we're doing some interviews as well, so hopefully you'll find some videos in there with the interviews with the authors so they can figure out how they built it. It's a resource to be inspired and then also to learn. And what I'm going to do today is I'm going to go through about 3 of the demos that have been published on the website. I'm going to explain how it was built, and we're just going to go through it that way. So the first one, the Mojifier. Okay, it's not trademarked. It's just the Mojifier. So thought it looked good. So the Mojifier is going to change the world. Okay. What it does, takes an image. Any guesses? There's always somebody goes, it mojifies it. So congratulations, you get a sticker. So yes, what it does is it takes an image of a face, figures out the face in the image, where it is, okay? Figures out the emotion in the face, okay? Then calculates the matching emoji and puts it on the face, okay? That's the Mojifier. That's it in a nutshell. I originally released this as a Twitter bot, but before you get excited, I don't want you to get too excited about this. I originally released it as a Twitter bot, so if you went onto Twitter and then you saw any image and you replied with a hashtag Mojify, it would then Mojify. Don't get excited though. I got what's called shadow banned on Twitter. Has anybody heard of the term shadow ban before? It's the worst type of ban you can ever have on Twitter. You get banned, but nobody tells you you're banned, and you can still tweet. But all that happens is that nobody can see your tweets, and everybody stops liking your tweets. Okay? It's a bit of an issue for you if you've got anxiety problems like I have. And it's very, very hard to debug, I tell you that. But anyway, I got shadow banned. So in fact, I've recently re-released this as a Slack bot. So I'll give a link to that later on. But there's some interesting things about this application, right? How do you calculate emotion on a face? How do you actually do that? Yeah? I want to tell you, it's actually really, really, really easy. Okay, really easy. It's only got 2 steps. Only 2 steps. Okay? The first step is you need to use some sort of vision library to actually calculate the different features of a face. So there's some very, very important standard features of a face. The pupil locations, I've forgotten what this is called. There's different various locations on the face. There's a number of different open computer vision libraries that let you do that. Okay, so there's lots. It's easier to do that these days than it was before. And the second step, really easy, is just to use an artificial neural network. Okay? Yeah? Real good, right? Do you want me to explain an artificial neural network? Yeah? Okay, fine. I'll go into it. So an artificial neural network is it's based upon, it's got actually a basis in biology. Okay? So this is a real biological neuron. You have dendrites coming in, a body, and an axons going out. So if enough electricity flows in through the dendrites, the body goes, okay, now enough electricity has flown in. I'm going to pass some electricity out again. Okay? And if you throw enough of these things together, you get a human brain. That's it. Right? Yeah. Personally, I believe there's a little bit more to consciousness than a bunch of neurons, but everybody has their own beliefs. But what you can do is you can actually convert this into something in code. And if you think about it, it's quite standard. It's not so hard to understand how you might do this. It's just a graph. So you have these edges going into the graph, a node, an edge going out. Okay? You then might pump some values in. So for instance, I might pump some values in. This may be the number of McDonald's in an area and the percentage house price decrease in London. This is an actual study done in London a while ago. It's inversely proportional. House prices inversely proportional to McDonald's and proportional to coffee shops. And then what you do is the edges have weights that you would initially just randomize to some values. Yes? Initially randomize to some values. And then what you basically do is you multiply all of these things out. And then the end value, sum it up, and you pass it through something called an activation function. And then wherever that activation function passes out, you pass that out. That's it. Just to watch the screen, there's going to be some animation now. Just explain a little bit more of what's going on here. This is it. Okay? It's just multiplication. All we're doing here is multiplication. We take the input values, we multiply them by these weights, we sum them together, we pass it through an activation function, and then whatever that activation function pumps out, that is what gets passed onto another one, onto another one, onto another one, and you get enough of these together, you get an artificial neural network. What's an activation function? There's loads of different types of activation functions that you use. You need to think about which ones you need for various use cases. This is a very simple one. It's very binary. So if the input value is below 0, it's 0. If it's above 0, it's 1. Okay, it's not so great for some use cases because small values result in big output values. So you might want to use something like hyperbolic tan, kind of more gradient, or something like reactivated linear unit. But basically, whichever one you use, you get a bunch of these perceptrons, little neurons, and you connect them together into a neural network. That's it. Okay, that's it. You initialize, so this is a very, very, very simple neural network, has 3 inputs, 1 input layer, 1 output layer, 2 hidden layers in between. That's what we call a hidden layer. You initialize it. You initialize all of these edges with random numbers. I mean, this is just code. We're just initializing a bunch of random numbers. That's all you're doing. And then you pump some values in. Maybe these values are the different positions of the pupils, of the mouth. You can imagine if you want to detect a smile, you could detect it this way. You pump those values in. It just multiplies all those values together and gives you an output number. This is a very, very simple neural network. Gives you an output number. Maybe 0 is unhappy and 10 is happy. But we all know that 3 is probably wrong for this picture of me because I'm usually looking very happy. So we know that 3 is wrong. So we know this neural network is giving us the wrong result, right? So it's probably, I know I'm probably an 8. So I know it's off by 5, okay? And this is the kind of the magic of a neural network is how do you then, if I know I'm off by 5, how do you change those little weights so the next time you pump those values through, it gives us an 8. And that's called backpropagation. That's called backpropagation, okay? And it's the process of then tweaking those weights so that the next time you pass those values through, it will give us an 8. That's the training process. That's what you're doing when you train. That's the machine learning part of a neural network. And that's what you can do. There's actually data sets out there with lots and lots of different pictures that are labeled already with people, this is a happy person, this is a sad person. You actually need lots and lots of different examples because for one person, a picture might look happy, to another person might look sad. You need lots and lots of different examples. But if you get them enough, you can train a neural network that can give you the answer of whether somebody's happy or sad. Okay? You can do that. You can do that. Or you can use an API. This is what I use for Mojify. I use an API. It's the Azure Face API. I always find this a really unfortunate picture that we have on our website. I don't know if you can see it. She looks really confused. I don't think we should have a picture of somebody looking confused. But this is all you use. This is what I use for the Mojify, and all you have to do is post a path to an image, or you can post up the binary data itself, and it will turn you a bunch of information. This is actually a subset of the information, so it gives you the positions of the faces, right? Which is very important if you want to place an emoji. Remember, that's what we're doing, placing emojis. You need to know the positions of people's faces so you can place an emoji, but we also return an object of emotion, so anger, contempt, disgust, fear, happiness, neutral sadness, and surprise. Little bit of a fact here right now, if you have a beard, you can never be 100% happy. I've tried. It's impossible. So just to summarize, neural networks are just incredibly powerful. Neural networks are I'm going to stay this distance. It's as far as I'm going to go. Stay here. Neural networks are incredibly powerful, okay? They've driven a large part of what's been going on in the machine learning space, a large part of the real breakthroughs of the past couple of years, right? But the thing I wanted to get across is that conceptually they're really easy to understand, okay? I showed you the basics of it in about 5 minutes. They get much more complicated, but the basics of it you got in about 5 minutes. I hope you got in about 5 minutes, okay? Next demo. TensorFlow, MobileNet, and I'm fine. Now this might need a little bit of an explanation. If you can read my t-shirt right now, it says puppies, Azure, and I'm fine. So we did a Microsoft conference earlier on in this year where our team specifically, inside the middle of this very normal conference, we got lots of puppies. So as you're walking around, you could play with puppies, stroke them. It's supposed to be for therapy, makes you much more relaxed. And we all got these little t-shirts, puppies, Azure, and I'm fine. And I gave a workshop in London a couple of months ago where I was wearing one of these t-shirts and I was teaching people how to use TensorFlow. And so one of the attendees for the workshop, a guy called Oliver, actually went away and then created a demo called TensorFlow, MobileNet, and I'm fine. And that's the next demo I'm going to talk about. So it's pretty simple. It's a code pen right now. You can, I haven't got the link to it. Oops. It's a code pen. I've got a video of it working right now. So what it does is, I don't know if you can see, yes. So it's doing a search on Unsplash for an image. And it's examining the image and then telling you what it thinks is inside the image. Okay, so that's puppies has returned a, this is, what is that? I'm fine, platypus, duckbill, paddle boat. Okay, it's not great. Okay, what about this one? Fountain, it's not that good. Okay, puppies. Okay, it's got terrier. Okay, it figured out 9.46%. It's a terrier. Okay. Right, so sometimes it does an okay job, and sometimes, often it does a bad job. But the important thing I want to show you about this demo, okay, is that the only API call it's making is to unsplash to get the image. Everything else is happening inside the browser. The detection of what's in the image is happening inside the browser. All right? And it's using a technology, well, the hint was in the title, it's using a technology called TensorFlow. Does anybody here use TensorFlow? I don't know why I cannot see anybody in this audience right now. Anybody using, okay, cool. So what is TensorFlow? Why is it so cool? So TensorFlow is a technology open sourced by Google, I think 3-4 years ago. And it's you can do it for a number of different things, but it's a tool that allows you to train, but one thing it's really good at is to train neural networks. It's a way of doing that kind of training process that I showed you before. It's a way of doing that distributed across all the different nodes in a GPU and across a bunch of different nodes on a bunch of different servers. So it's really, really powerful for doing a bunch of stuff like that. But recently, I think 5 months ago? 5 months ago, they released TensorFlow.js. Okay. When I first heard about TensorFlow.js, what I thought was it was bindings for TensorFlow, the installed application. I thought you had to install TensorFlow on your computer, and once you'd installed it, you can then interact with it with JavaScript. That's what I thought. But it's not. It's a complete rewrite of TensorFlow in JavaScript. Complete rewrite. What does that mean? It means this. It means in order to use TensorFlow, in order to do machine learning in the browser, in JavaScript, all you need to do is, well, if you're a proper developer, you'd probably use the top one, right? If you're like me, you'll use the bottom one, okay? But this is it. All you need to do is add one JavaScript library, and you can do machine learning in the browser, right? As a JavaScript developer. Very exciting, right? And there's a bunch of different things you can do with it. You can train models. So you can do that thing I showed you before with the neural network, and you can initialize values and backpropagate and train them and tweak the weights. You can do that with it. But another thing you can do with it is load a pre-trained model. Okay? There's lots of different machine learning models out there. You can download them. They've got converter packages that you convert them into JSON. You can load them up in TensorFlow.js. So you can actually have something that's been trained using Python, then load it up using JavaScript. Okay. And what Oliver had done is he basically used one of those packages called MobileNet. Okay, MobileNet it's been trained up to recognize about 1,000 different images. It's small enough so it can be loaded up in the browser, and that's what he used. So you can see it's actually only got a few lines. This is it. This is it. You load up MobileNet, you get an image tag, you load the model. The model's quite large, and then you pass it to classify, and it gives you those percentages of what it thinks inside the model. It's not very good, okay, but it's fine. You actually use things like this for something else called transfer learning, which is more useful, but we don't have time to go into that today. You could do that. You could do it that way, or you can use an API. So there she is again. I need to speak to my Microsoft people and get some images changed. But yeah, we have something called the computer vision library, which kind of does similar things. Because the MobileNet, to be small enough to be loaded up in the browser, it can't really detect a lot of things. If you want to detect a larger range of things, you need to use a much, much larger model, which isn't really feasible to be loaded up inside the browser. So you want to put it on a server somewhere and wrap it in an API. Lots of different cloud people, companies out there have APIs that let you do this. We've got one called Computer Vision. My colleague Sarah Drasner created a cool little demo. Again, this is on AI-JS Rocks as well, but she created a cool little demo which is for accessibility. Okay, so in a website, it can examine an image and create an alt text to put in for screen readers. Okay, this is her demo, and it's kind of a bit crazy. If you actually pass this image to the Azure Computer Vision API, it returns that caption at the top. A black and white photo of Thomas Edison. The text says, "Hey girl, did we just share electrons because I'm feeling a covalent bond between us?" I don't understand that joke, I'm sorry. But the important thing I want to show you about this is that it didn't just say a black and white photo of a guy. It knew it was Thomas Edison, and it extracted the text from the image as well. So it does a whole load of other things. But it doesn't always get it right, okay? As with everything, nothing's perfect. This is a couple of other people, once you released it, posted on Twitter, other answers it was giving. So this is a star-filled sky. The text says, I think that's Asian for something. The next one, I'm not too sure. I think the next one could actually be correct. But a group of stuffed animals on a bit. They could be stuffed. You don't know. Maybe they are. The next one I really like because I think we were half right. I think we're half right with the next one. Dog closing. Half right. Okay, so pretty good. Just to summarize, okay, so the thing that if you're going to take one thing away from this talk, if you want to take one thing away from this talk, just take this. TensorFlow.js doesn't have any dependencies, okay? You can just drop it into an application and start doing machine learning in JavaScript. That's it, okay? MobileNet is a really simple way you can use to analyze images. We use it for other things, but it's a really easy way to get started. And if you really want to do something more important, more significant, you need to use an API right now. So Azure Computer Vision is a good API that you can use for that. Okay, I'm running out of time. I want to get to the next one, because the next one is my favorite. Right, image to image. I'm just going to play a video. Okay, so image to image is a really good demo, really fun. What does it do? It basically, if you draw the outline of a cat, it will fill in the rest of the cat. Okay. It's a really good demo. It's by a guy called Ziad, who I interviewed. His interview is going to go on AI-JS Rocks shortly. He's still a student. I was not doing stuff like this when I was a student. But yeah, really interesting stuff. But I want to talk to you about how he made it. He made it using an algorithm called Pix-to-Pix and a system called generative adversarial neural networks. Okay, the really interesting space. And hopefully I'm going to have time to take you through it all. So a generative adversarial neural network is actually two neural networks competing with each other. Right? So you've got one, which is the generator, and the other one, which is the discriminator. So the generator's job is to create images of cats. The discriminator's job is to detect if the image is a generated image or a real image of a cat. Okay? But again, these are just neural networks. So they're initialized with a bunch of random values. What you pass in to the generator is a sketch of a cat, just a sketch. You pass it in. I'm too far away. You pass it in, and remember the weights are all randomized initially. They're all randomized. It's not really going to create a good image of a cat. It's probably just going to create static. Okay? So for all the sketches, it generates a bunch of static images. And then it passes that through, it passes all those images to the discriminator. I'm just going to give up on that. To the discriminator. And then the discriminator gets all of the static images and all the real images of cats. And it then has to go and figure out if it's a real image or a fake image. Okay? Again, the discriminator is randomized at the start. So it's not really going to do a great job to begin with at discriminating. Right? So, for instance, it might say the cat is the fake image and the static is the real image. It might say that to begin with. And then it would be wrong. And once it's wrong, what do? You want to retrain those weights so next time it does it better. So if it's wrong, it would then retrain the weights and the discriminator. So next time it gets asked, it does a better job. But if it got it the other way around, then the generator knows it's wrong. So the generator then gets retrained, and the generator gets better at generating images. Until eventually what happens is the generator gets really, really good at creating cat images, so good that the discriminator can't really tell the difference. Can't really tell the difference. Okay? And so then it's done. It's done, it's created. Okay? And then what you take is you take that generator model, and what Ziad did is he exported that into a format that can be used in TensorFlow.js and put that in the website. Okay? And so then what you have to do is input your own sketch of a cat, and it's going to try and create a sketch of a cat. It's going to try and create a picture of a cat. Right. Why is this important? Like joking around with cats, right? Why is this important? What's the significance of this? I think this is one of the most important parts of machine learning that's been coming along recently, especially to all of you here who are web developers. Because you can do a bunch of different things with it. So the stuff I'm going to show you now does not work in the browser yet. Okay, but then this is another similar algorithm called vid to vid. Okay. So the images on the right are generated from the images from the sketches on the left. They're generated. Right? Okay. Gets a bit more interesting. You can create different people. How about this? She's not dancing. This is a segmented image of this is somebody else dancing. They segment the image, and it's been layered, and it kind of like it's generating her image dancing, if that makes sense. Okay. There's this one. This is another interesting one. So it's a segmented image. So the top left is the input image. There's different algorithms playing along here. The top right is a pix-to-pix, literally the same algorithm that was used to generate the cats. But it's for picture by picture, for frame by frame, so it's not so good. Vid to vid is the bottom right. It's pretty good. It's generated. If you actually look very, very closely, it's got some issues. There's kind of a blob walking out of a car without any legs, things like that, right? And it gets even more interesting. Hopefully, I'm going to be able to do it here. So something we created inside Microsoft is we can actually create images of birds. So does anybody want to describe to me an image of a bird? A what color bird? Red? Red bird with what color beak? Blue? Anything else about the bird? Small, pointy feathers? Yeah? 2 heads? Let's try it. Okay, well, I think that's enough for now. Okay, it's created it. Okay, pretty... Well, we said red with what did we say? I can't remember. Anyway, so this is generated. Okay, this is generated by various algorithms and created in the browser. And this again is generated using a generative adversarial neural network. All right, pretty scary, right? Yeah. How far away do you think we are? How far away do you think we are from creating something where you can type in, make me a website with a header, a contact button, etc.? How far away do you think we are? Yeah, I created something. It's called FormGAN. It generates a form for you. Yeah? Does anyone want to give me a form? So a form with 3 input fields. The first is a text area. What next? The next is a file picker. File picker. And the third is a password field. Yeah. You ready? Thank you. So, it doesn't exist. I was just joking. I asked Ole for a song. He said this was his favorite song. And he said all the Ukrainians would love this song, so that's true. So, it doesn't exist, right? But we're not far off. I showed you something that made birds, right? That people really are working in this space, and there are things happening here, okay? So, scary. Or maybe not so. So just to summarize, so GANs, they learn to generate new images, okay? They actually take a lot of compute to train, more than a normal neural network, okay? So, but the generated models that they create can be run in the browser. So they take a lot of compute to train, but you can actually optimize it enough to download it and convert it and have it to be used in the browser with TensorFlow.js. A few other things I want to just leave you with. If you want to find out more information, if you want to learn how to build something like the Emojifier, I've got a link here you can go to. You can take a picture. Please take a picture. You can take a picture, that link will take you to something that shows you how to create the Emojifier. I also want to say, I'd recommend, if you are interested in to learn a little bit more about TensorFlow.js, Tero is going to be speaking next about music and AI in the browser with TensorFlow and Magenta.js. So he's going to be talking about how to use TensorFlow.js to make music in the browser. So stay here if you want to go for that. Final thoughts. Just a few final thoughts. I just really want to, I know I scared everybody here in the audience, hopefully, with this talk today. But I just really wanted to tell you, it's the question I've been asking myself at least for the last year, okay? So where do we fit in as web JavaScript developers? Where do we fit in into the AI machine learning revolution that's happening throughout the world right now, okay? And I'd say that kind of 20 years ago, we were just web developers. That's all we were web developers. And now we've got all these different roles, front-end, back-end, UX, product, DevOps. As a field grows, the specializations appear for the different fields, okay? So I see a future where there's a specialization for a JavaScript developer in the machine learning space, a machine learning JavaScript engineer. For our meetup in London, the AI JavaScript meetup, when we created it, we expected the only people to turn up to be JavaScript people wanting to learn machine learning. But actually half the people who turn up to our meetup are data scientists, machine learning engineers who want to learn JavaScript because it's a great way of taking this amazing work that they've done and productionizing it and making something actual, tangible on the web with it, okay? So that's what I'm going to say, is I think there's a future where there's going to be a machine learning JavaScript engineer, and you don't need to know, you don't need to sit there and read PhD papers all day. You just need to know the basics, okay? So that's it. Thank you very much for your time.